Now let's see what happens when you have to calculate the pH of a weak acid instead of a strong acid. Let's take, for example, let's pick the yellow, the acetic acid. In aqueous solution, as this is a weak acid, you will get the acetic ion in aqueous state and the hydrogen proton. Let's pick out the number, an amount, and let's say 0.2 molar. Let us form the ice box. Here we have the initial amounts. Here we have the change in the initial amounts, and this is the equilibrium. So when we start, we don't have any of this, neither of this has been produced. When this dissociates, it does not dissociate fully, it's a weak acid, it's a weak electrolyte, so only a small amount, let's say X, reacts. So we subtract from the initial value. And because the coefficients of the stoichiometry is 1, 1 and 1, when X reacts, it will produce X molar and X molar. So in equilibrium state, we'll have 0.2 minus X molar, X molar, and X molar. In order now to move on, we have to combine the equilibrium concentrations into one expression. This expression will be the equilibrium constant for the acid, Ka, for our weak acid. So this will be the concentration of the products over the concentration of the reactants. Here's only one, it's our acid. If you look at the tables, the value for the equilibrium constant of the acetic acid, the ethanoic acid, it's 2 times 10 in the minus 5. This is true at 25 degrees Celsius. If we substitute X minus X times X, sorry, as we see in the equilibrium expression, equilibrium state, over 1 with 0.2 minus X equals 2 times 10 in the minus 5. If we try to solve this, this is a quadratic equation, it might get a little bit tricky. So what we do, we make a test. We take this fraction, this is the equilibrium constant for the acid, and this is our initial concentration of the acid. This will give us 0. If you move upwards, it will be 4. So it's 10 in the minus 4. This is smaller than 10 in the minus 2. This is a reference point. Because this is smaller, this test fraction is smaller than 10 in the minus 2, we can say with high confidence that the X can be ignored in relation to 0.2. So 0.2 minus X can be seen as just 0.2. This is very, very small. So the above expression will be X square 0.2 equals 2 times 10 in the minus 5. So let's move it downwards. X square will be 2 times 2 times 10 in the minus 6. So X will be, if we use the square root, it will be 2 times 10 in the minus 3. This is the concentration of either the acetic ion or our proton ion or hydrogen proton. So what we want to calculate for the pH is the concentration of the hydrogen proton. So this is our concentration. In order to calculate the pH, we need the minus log. This has a base of 10. As we already know, of that concentration, it will be 2 times 10 in the minus 3. So this is going to give us minus log 2 plus minus log 10 in the minus 3. Log 2 is 0.7 plus 3. This equals 2.3. So the pH for this weak acid at 0.2 molar will be 2.3.